Okay, for this example, we're given the magnitude of our vector is 8, and the angle that the vector is making, and this would be measured from the x-axis again, is 45 degrees. And we're going to write this in AI plus BJ form. Remember that I is our horizontal component and the j is our vertical component. And so we can write this for our vector. Remember, we're kind of combining all of our forms here. We're saying that the vector, that's kind of like our radius. So we can take the magnitude of the vector, and then as far as our I component, we can find that by taking the cosine of our angle. And that's going to give us our I component. And then the sine of the angle will give us our j component. Now we know that the cosine of 45 degrees is equal to square root of 2 over 2. And sine of 45 is also square root of 2 over 2. And we're still going to take this times 8. Remember, that's the magnitude of the vector. Again, this looks very much like polar form. And now we distribute, and so our vector in AI plus BJ form is 4 square root 2 for our I component and 4 radical 2 for the j component. Some vocabulary for this section: we have a static equilibrium, which we're saying an object is at rest, it's not moving. And so what that means is that the sum of all the forces acting on the object is equal to 0, and that's what we'll use to set this up. And then also resultant force, we could think of these as vectors. We have one vector plus the other vector gives us a resulting vector, or force 1 plus force 2 gives us a resultant force. And when we're doing that, we would add our I components and our j components. And that would give us our resultant force. For this example, we have static equilibrium. We're saying that we have this 1,200 pounds hanging here. And so we have, let's say we have a beam across the top, and then we have a chain anchored at this point and a chain anchored at this point, and then together they come here where the weight is hanging. So we have force 1 over here from this point coming back this direction, force 2 from this point coming here, and then force 3 from this point coming down. And so from this point, nothing is moving. This is where we have these three forces together coming to add up and equal 0. So when we're setting this up, what we're going to think of is, imagine a line. Here's our x-axis basically coming across here through this point, parallel to this line. And so now what we're thinking of is we need to find our angles. So we have an angle coming here, which if we have these lines are parallel, then we would know that that angle would have to be 45 degrees because those are alternate interior angles. We would also have alternate interior angles over here giving us 30 degrees. So then we could find our angle coming all the way across to here would have to be 150 degrees since this is 30. And then our angle coming all the way around here to force 3, which is going straight down, would have to be 270 degrees. So we're measuring from the x-axis, same way we have with everything else. So now we're saying we have force 1, force 2, and force 3, which we're going to write as vectors. And again, if we're thinking of this as, we can almost put this in polar form, or our magnitude is our radius for each of these. We don't know what that is. Let's say that we have force 1, we'll say is A, as far as that magnitude goes, or our radius. And then vector over here for force 2, we're going to have that as B for our variable. Force 3 we'll have as C. So what we need to do is we take the magnitude of A, and then we have the cosine of our angle. In this case, that was 150 degrees. That's our I component. And then we have the sine of that angle, and that's our j component. We're saying the same thing then for force 2, only now we're talking about B, and our angle has changed. That's our 45 degrees. So we have the cosine of 45 for the I component and the sine of 45 for the j component. And then our magnitude here for C and cosine of our angle, 270 degrees. That's our I component. And the sine of that angle. And this is our j component. All right, so now we have that set up. Next, we'll set up our equations. Okay, so from here, we do not know what the value as far as our A or B is for the magnitude of those two vectors. C, we do know that we have 1,200 pounds of pressure pulling there. So that's our force on that we're looking at. Now we can find the angles here. Cosine of 150 is negative square root of 3 over 2. And that is our I component. And then the sine of 150 is 1/2. That is our j component. Then on our next one for force 2, we have cosine of 45 and sine of 45, both of which are square root of 2 over 2. So that's both for our I component and our j component. And then for cosine of 270, that's equal to 0. Sine of 270 is negative 1. So we do not have an I component here. That would be 0. And then we have negative 1 for our j component. So what we've done now, remember what we're trying to say is that we have our force 1, force 2, and force 3, that when we add them together, that's going to equal 0. So now if we were to take these same values, and let's go ahead and distribute our A. So what we end up with then for force 1 is negative square root of 3 over 2 AI, and then 1/2 A and J. And then for force 2, I'm distributing that B value, so now we're going to end up with square root of 2 over 2 B and I, and then we have square root of 2 over 2 times B for our J component. And then force 3 is a negative 1,200 for the J component. Now again, we were saying that force 1 plus force 2 plus force 3 equals 0. So now what we're going to do is we're going to plug in these values for our force 1, force 2, and force 3. And so that's going to look like negative square root of 3 over 2 and 1/2. That's our force 1. And then we have force 2. And then we have our force 3. And all of this is equal to 0. Now if we're going to be adding these vectors, what we do is we combine our I components and our j components. So here's our I components, and then here is our j components. And so if we put those together, here we have a negative square root of 3 over 2 and positive square root of 2 over 2. That's our I component, taking these two values. And here's our j component. And again, this is still equaling 0. So now from this point, what we need to try and do is we have two equations and two unknowns. And so we're going to solve for one in terms of the other and plug that back in to figure out what our force is for force 1 and force 2. So if we take our negative square root of 3 over 2, taking our I component, we're going to say that that's equal to 0. And now let's solve for one or the other, and it doesn't make a difference which. So let's, for this example, let's subtract the square root of 2 over 2b over to the other side. And then we'll multiply by the reciprocal on both sides here. We're going to have to rationalize the denominator. So when we multiply by the reciprocal here, of course we're canceling all of this out, so we have a is equal to, and negative times a negative makes that positive. Our 2's are going to cancel here. We end up with a square root of 2 over a square root of 3 times b. We can rationalize the denominator at this point if we want to. We are going to end up using the calculator here shortly. If I multiply top and bottom by square root of 3, we end up saying that we have the square root of 6 over 3 for our b value. So we've just solved in terms of b what our a value would be for this part of our equation. Now we're going to plug that back in to this side. Alright, so what we would have is 1/2, and instead of a, we're plugging this in. So we're going to substitute in square root of 6 over 3 b in for our a value. We still then have plus square root of 2 over 2 b minus 1200. We're setting this now equal to 0. And now for this, now we can solve for b. So we could add the 1200 over to the other side. We can multiply here. We end up with square root of 6 over 6 plus square root of 2 over 2. This still is b. This is b. This is equal to, move the 1200 over. Now from here, let's see if I multiply top and bottom here by 3, that gives us a common denominator. So we have square root of 6 plus 3 square root 2 all over 6b equals 1200. What we're really going to find out here is what our force is on b. So I can now at this point, if I want to find a decimal value, I can use the calculator now here. Let's say that we have square root of 6 plus 3 square root 2, and we're dividing that by 6. Okay, so that is our value here times b, and we're solving for b, so I'm going to divide that over to the other side. So I'm going to take the 1200 and I'm going to divide by my answer. And so we just found that the force on b is 1,075.9 pounds. Now the next thing we do then is go back to what we just solved here for a, and we can find the force then on a. Again, let's plug that into the calculator. So we'll take that value times the square root of 6 and then divide that by 3. And then the force on a is 878.5 pounds. And so going back to our first part of the problem here, when we look at this, we already knew that force 3 was 1,200 pounds this way. We just solved then and found that force 2 was 1,075.9 pounds here. And then on force 1, we have 878.5 pounds this way.